Good morning. How is everybody today?
I'm tired.
Finally, at least it's Thursday. You got the weekend coming. All righty. So we got a couple more to join in, but we'll go ahead and kind of get started. I wanted to start out with reviewing 8.6. We had started talking about our triangle proportion theorems. And so that's what we're going to start off with. First of all, is kind of reviewing those four that we had just talked about. So before we get started, any questions on anything before we go? All righty. So let's go ahead and start on page 498. Back up to 498 for just a minute, proportions and similar triangles. And so the first one was we looked at, and it said, if I have two parallel lines in a triangle, so basically if I've got a line parallel to one side of my triangle, then I can look at my parts of my sides that are proportional to each other. And then the converse of that was if I have the parts of the sides that are proportional to each other, then I've got parallel lines, okay? And then on page 499, we looked at two other theorems. And the first one was the one I said, railroad tracks, and then the other one was the bow and arrow. But 8.6 says if I have three parallel lines and they intersect two transversals, so three parallels, two transversals, then they divide the transversals proportionally. So three parallels divide two transversals proportionally, okay? And then we can see those parts of the transversal that are proportional to one another. And then here comes April. And then on theorem 8.7, that was the one that I said kind of looking like a bow and arrow on theorem 8.7 on page 499. It just says if a ray bisects an angle of a triangle, we've already talked about that a bisector of an angle means it cuts that angle in half. So if we have a ray that bisects the angle of a triangle, then the opposite side is divided into segments, and those segments of the opposite side are proportional to the lengths of the other two sides, okay? So, so those are going to be my rules of proportionality for triangles, those four different things that we looked at. All righty. So I think we had just finished talking about the ray bisecting, and did everybody get the notes for that so far for number 4? Did you draw your diagram, write your if-then statement? And that's 8.6, number 4. If you haven't done that, then that's where you'll need to pick up. And then we're going to go ahead and starting. So let's see, let me get my screen going. I always forget and change that first. I'm going to share the screen before I can pull it. Okay. All right, so we're starting with example 3 on page 499. Get Easton back in here.
Sorry, my internet went out.
That's okay, and I'm trying to do the best I can. I keep my participant box open, so I can see when somebody needs to get back in, because sometimes if I'm looking down and looking at what I'm doing instead of looking at the screen, I miss that. So I will try to, if you get kicked out again, I'll always try to make sure that I'm trying to keep an eye and make sure that everybody is in. All righty. So we're starting with example 3 on page 499. This is using our first theorem that we just talked about, how if I have 3 parallel lines that bisect or that intersect 2 transversals, then I can see that the portions of my transversals that are proportional. Okay, so real quick, notice that in our example in the theorem, they showed us, get comfortable with knowing that you can see it horizontally side to side, and then now we're working with it vertically. Now again, it's the kind of thing where if you can see it better horizontally and you want to redraw it in a horizontal pattern, you can always take that, or when I've been working with students, I've even actually taken the whole book and just turned it sideways. Depends on which way you can see it better. But if you're comfortable going between the two, then that is fantastic. All righty, so it says in the diagram, angle 1 is congruent to angle 2, which is congruent to angle 3. So we see that those 3 angles are congruent. We see that PQ is equal to 9, QR is equal to 15, and ST is equal to 11. What is the length of TU? All right, so I can see that PQ to QR is proportional to ST over TU. So basically I'm looking and I see that this over this is proportional to this over this. So I can set up that proportion and say 9 over 15 is equal to 11 over x. 9 times x is 9x. 11 times 15. Go ahead and 11 times 15.
115?
No, 11 times 15 is going to be 165. Close. And then divide by 9. Divide by 9. And we end up, so again, this is going to end up as a decimal. So 165 divided by 9 is going to be 18.3 repeating. But if you went ahead and kept it as a reduced fraction, they're both divisible by 3, so you end up with 55 over 3. So you can either have your reduced fraction or your repeating decimal, okay? So you can either have 55, which you could also have 18 1/3 also. So all of these are going to be the same, so you can represent your answer the way you want to, okay? But the main thing is being able to look and see which sides correspond, how to set up those proportions. Any questions on that?
Could you simplify that to 18 or no?
I guess if you wanted to round it, it's the kind of thing where y'all know I'm fairly lenient on if it's something that's a rounding issue and they, I guess in most of these we've seen where they have represented answers. We haven't in the book, they haven't necessarily gone with decimals unless they're actually decimals in the problem. I would accept a whole number 18. So anyway, but just know that if you ever saw like a multiple choice question, you just know that you've got to find the one that represents your number the best. Okay, hang on just a second. Sorry, my daughter had texted me that asked me if I could deposit her check into her account because she's locked out of her account and she needs money. So I'm thinking like she needs money right this minute. No, just sometime today because she had gone to breakfast with some friends. So I had visions of her sitting at the restaurant not being able to pay her bill because her card wouldn't work or something. But no, anyway, you teenagers, y'all are something. All righty. So that is dealing with our theorem 8.6 on proportionality with 3 parallels, 2 transversals. Okay. Now we're going to look at the next one, example 4. This is going to be dealing with our other theorem where we talk about if the ray bisects an angle, then the opposite sides are going to be proportional to the 2 other sides. So in this situation, I know that this over this is going to be proportional to this over this. Okay. Is everybody good with that? This one's a little more challenging to visualize. You know, the other one, when we look at it, we're seeing that, hey, these make sense because you know, here over here equal to here over here. I can, that they're corresponding locations and things like that. So it's a little bit easier to see. But when I'm right here, since I'm dealing with all the different sides of my triangle, it's a little more challenging, but just know if you see that bisector, then you're looking at the 2 sides that it's intersecting over the other 2 sides of the triangle. All right, so we just said we have angle CAD is congruent to angle DAB. Use the given side lengths to find the length of DC. So we're trying to find DC. Now notice that it tells me that AB is 9, AC is 15, but I can see my entire segment, B to C, is 14. Okay, so if I don't know what either of those sections are, the only way I can figure out what each section would be 14 minus BD or 14 minus DC. So 14 minus BD is equal to DC, and 14 minus DC is equal to BD. So remember, if they haven't given me an actual measure, I may end up having to use a variable to represent that and subtract it from 14. So that's what we're looking at over here. Okay, so I can see that AB over AC, so AB over AC, so that's going to be 9 over 15 is equal to, oh, here comes Keely. Let's see. So I've got AB over AC, 9 over 15 is going to be equal to BD over DC. So let me start out first by writing that in letters, and the book did it, but I want to go ahead and, so AB over AC is equal to BD over DC. Okay, so in that example, we can see that when I look at AB, AB is 9, AC is 15. Now BD, we do not know what it is, but we know that that's going to be, if we're trying to say, if we let DC be X, then I'm going to have 14 minus X is going to give me the value of BD. And then we're letting DC be X. Is everybody good with that? Since I do not know, let me erase this real quick. Since I do not know this measure or this measure, I'm going to let one of them be X. And then I'm going to write something that applies that that uses X and 14. So again, one of the things that I could do is if I had it flip-flopped and I had AC over AB is equal to DC over BD. Remember, I can flip-flop it like that. The other thing is if I let BD be X, then basically what I've got to do here is then I would have X in my numerator and then 14 minus X here. So again, it's not magic which one I'm deciding to call X. It can be this segment is X or this segment is X. I just have to make sure to put them in the appropriate locations. Okay.
So could you multiply X? Could you multiply everything by X? If you have 14 minus X over X, could you multiply everything by X and it'll still work or not?
Okay, so what we're doing is in this example, we're letting DC be X. So that means to be able to solve for BD, then I'm going to have 14 minus X. Does that make sense so far?
No, I was saying the bottom X. Could you multiply that?
Okay, so what we're going to do is remember this is a proportion. I'm not trying to clear fractions, I'm doing proportions. So this time I'm going to have to cross multiply. Oh man, I need to cross multiply. So I'm going to have 9X is equal to 15 times 14 minus X. So remember, I'm cross multiplying. So that means I'm going to have to distribute this 15. So I'm going to have 9X is equal to, and let's see, 15 times 14 is 210 minus 15X. Okay. Then I'm going to add 15X and add 15X. 9X plus 15X is going to be 24X is equal to 210. Divide by 24, divide by 24, and I end up with X is equal to 8.75, or you could have that as 8 3/4, up to you. Okay, but the main thing is that if I do not know either of these measures, you've got one, you need to let one of them be your variable. So let one be X, and then the other is going to be the total length minus X. Is everybody good with that? But it doesn't matter which one. There's not magic in saying, oh, it's got to be, this one has to be X and this one has to be your total value minus X. Either one could be X. It just means that whenever I'm plugging it in, I make sure that if I'm representing BD here in my numerator and DC in the denominator. Again, BD could have been X, so that means DC would have been 14 minus X. Okay. So let's keep going. Let's go ahead and turn to goal 2. This is using proportionality theorems in real life. Building construction, you're insulating your attic as shown. The vertical 2x4 studs are evenly spaced. Explain why the diagonal cuts at the tops of the strips of insulation could have the same lengths. Okay. So we can see that our diagonal cuts, notice at the top because of the slant, and it says because studs AD, BE, and CF are all vertical. Remember, our studs are the ones that are running up and down. So because those are vertical, you know that they're parallel to each other. So using the theorem 8.6, remember 8.6 was where if I have the transversals that cut my parallel lines, we know that they're going to be parallel to each other. So we can tell that DE over EF is equal to AB over BC. And since the studs are evenly spaced, we know that DE is going to equal to EF. So it says, so you can conclude that AB is also equal to BC, which means the diagonal cuts at the tops of the strips have the same lengths. So each of those diagonals, the lengths are going to be exactly the same as they are cutting them. Okay. And let's go on to example 6, finding segment lengths. So turn the page. Nope, actually it's just below it, my bad. All right, so in the diagram, KL is parallel to MN. So I can see where my parallel lines are. Fortunately for us, they marked them with the little arrows so I can see my parallel lines. Now, when I look at those, again, it's the kind of thing where I want you to start getting into the habit of being able to look at this and saying, hey, then that means this is proportional to this, which means this is proportional to this, okay? So again, I can set this up and say, that 9 over 13 is going to be, 13 and a half is going to be proportional to JL to LN. Now here they have marked LN as X. So that means that right here, JL is going to be 37.5 minus X. Okay, since they've already said that this is X, my total length is 37.5. So JL is going to be 37.5 minus X. So I'm going to set up my proportion. 9 over 13 and a half is equal to 37.5 minus X over X. Okay, so again, I start out cross multiplying. 9x is equal to 13.5 times 37.5 minus X. Get my handy dandy calculator. Oh, that's not what I wanted to do. All right. So I'm going to have 9x is equal to 13.5 times 37.5, and that's going to give me 506.25 minus 13.5x. Add 13.5x to each side, and I'm going to end up with 22.5x is equal to 506.25. Divide by 22.5, divide by 22.5. So 506.25 divided by 22.5, X is equal to 22.5. Okay, so now we can see that if X is 22.5, then we can figure out that 37.5 minus X is 37.5 minus 22.5. So then that means that 37.5 minus 22.5 is going to give me 15. Okay. So I can find both of those segments now. I found that X is 22.5 by subtracting that from 37.5. I now know that the other segment is 15. Okay. So now we need to solve for Y. We found X, now I need to solve for Y. So now what we're thinking about is, again, my proportionality. So if you wanted to use the sides we just found, you could, or if we just go back to the original and we know that JK over KM. So I have JK over KM is equal to KL over MN. Okay, so I'm going to start out with the same 9 over 13.5 equals, and here I've got 7.5 over Y. Oh, I'm sorry, I did, let me erase so I can see better. Hold on just a second. I've got to do my whole side there, not JK over KM. I've got to do JK over JM. I wrote that wrong. So then that means that down here, I'm not doing 9 over 13.5. I've got to do 9 over the total measure of the side. Since I'm doing JK, I'm doing part to whole, okay? So now I've got that 13.5 plus 9 is where we had the 22.5. Okay, now I cross multiply, and 9y is equal to 7.5 times 22.5. 9y is equal to 7.5 divided by, and multiplied by 22.5 is 168. That's a 168.75 divided by 9, divide by 9, and y equals 18.75. Okay, so in this situation, we actually put both of our, we put two things together right here. We use the theorem that talks about, we looked at being able, or not theorems, we looked at two different things in this problem. Not only did we have to look at my sides being proportional here to here, over here to here, but then we had to work with our parallel lines. Okay, and so then we had to look back at like example 1, dealing with the length of our segment. And remembering that when I deal with the length of the segment, I'm doing part of one side to the whole entire side compared to, I guess, and really, let me do something real quick. I'm gonna try something out. So in that situation, I started out saying, no. I always like to see all the different possible ways that we can set it up. And I want to make sure parallel lines. Okay, so I guess that's the one showing us the formula to be able to find the segment lengths. So I was trying to flip back to make sure, but that was the first one that we found, finding the measures of the parallel lines. Oh, here comes Garrett. I think that's what I was trying to go back to example 1, where we were doing portion of a line over portion of a line is equal to portion of a line over portion of a line, but that's not what we were solving for. Okay, so what we've got to look at is when we are trying to solve for a measure of the parallel lines, notice I did my part of my line compared to the whole line. Okay, so my part of my line compared to the whole, over, so part of line over whole line is equal to small parallel over large parallel. Does that make sense? Because a moment ago we were just doing sides proportional to each other, but when we're actually finding the measure of an unknown parallel, I've got to have my part of my line over my whole part of my line. And then in my numerator, I have my small parallel over my large parallel. Okay. So that's going to be finding the measure of the parallels. All right. Now we're going to turn over to page 500. No, we're not. I'm already there. I had flipped back. We're going to turn over to page 502 and look at our guided practice. It says complete the following. If the line divides two sides of a triangle proportionally, then it is blank to the third side. So if a line divides two sides of a triangle proportionally, then it is parallel to the third side. And that was the one where we did the triangle proportionality converse. Okay, so we said if the line divides the two sides of the triangle proportionally, then we have parallel lines, whereas the triangle proportionality theorem says if I have two parallel lines, they divide my sides proportionally. So this is the flip-flop of that. So this is the converse. All right. In triangle ABC, AR bisects angle CAB. Write the proportionality statement for the triangle that is based on theorem 8.7. So on this, what I'm going to do is I'm going to go ahead and draw my little triangle real quick. So if I say this is A, B, C, and I've got my thing that goes like that. Okay, so it says ABC bisects CAB or AR. So this is AR bisects CAB. So write the proportionality statement for the triangle. So basically, if I'm looking at this, then that means that you could either start it as AB over AC is proportional to BR over RC. And actually my R, we can put him like he'd be closer to here, actually. Okay, so basically I've said that this side over this side is proportional to this segment over this segment. Okay, so AB over AC is equal to BR over, I guess, BR over CR or BR over RC. Yeah, RC, either way. All right, 3 through 6, determine whether the statement is true or false and explain your reasoning. Okay, so in this one, it says FE is to ED as FG is to GH. True or false? That's going to be true. Okay, we've got our parallel lines intersecting our sides. So where those two parallel lines intersect, I know that my sides are proportional. Okay, let's look at the next one, number 4. FE is to FD as FG is to FH. Again, that's going to be true. Okay, I've got a part to whole as compared to part to whole. So as long as I've got those same measures, as long as I've got using my corresponding, I'm good to go. All right, let's look at the next one. EG over DH is equal to EF over DF.
False.
That's actually just like the example we looked at a minute ago. Okay, so this is where I've got my small parallel over my large parallel is equal to the part of my line over the whole line. Okay, so this is true based on that this says angle postulate, but but that is going to be true based on that example we just looked at, where I have my small parallel over my large compared to short side, long side. Okay. Now, again, it could be compared to this short side to this long side. It doesn't matter which side I compare it to. Okay. It's still going to be a true statement as long as I'm making those proportionality statements. And then finally, ED to FE as EG to DH. And that's what I was trying to do a minute ago. And that is not true. Okay, I can't take part over part to parallel over parallel. I can only do part over whole to parallel over parallel. Okay, so that's going to be one thing to remember, that when you're solving for the parallels, when I'm comparing the proportionality of my parallels, it's the part of one side compared to the whole side that is proportional to parallel over parallel. Okay, the only time I can do part to part is when I'm comparing it to another part to part. Any questions about that? All right, the next one says use the figure to complete the proportion. So here I've got BD over BF. So I've gone part to whole or to bigger segment is proportional to something over CG. So I can see that it's going to be this right here. So that's going to be CE. If as we're doing these things, if you can't see it and you're not sure, be sure to let me know. Okay, let's look at the next one. AE, so AE is going from here is to CE. So I've gone a bigger segment to a smaller segment. Now I have a question mark to BD. Okay. Let me make this a little bit smaller, make sure it doesn't go over that line. So we said AE here and CE.
AB.
So if my big section was first, I'm sorry, say that again.
AB.
Not AB, it wouldn't be just this short little part. It's got to do the whole segment because I did whole segment to small. Now I've got to go whole segment to small. So it's actually going to be AD. Okay. Let's look at number 9. I have something over GA. Notice GA is going to be this whole entire segment here. And then I'm comparing it to FD, which is the small part here, to FA.
GE.
So the part that I'm missing right here is that GE. Good. All right. And then finally, I have GA. So again, we've got that whole section over something is equal to FA, my whole segment, to DA.
EA.
So what part would I'm sorry?
EA.
EA, good. Yes. So that's going to be EA. Good job. Okay, like I said, tracing it with your finger is actually drawing over it, you know, whatever you've got to do to be able to see it, if that helps. If you can't immediately pick it up and you're not real sure and you need to see the actual marks to show you, then do what you've got to do, okay? That's one of the things I also tell when I'm doing ACT prep, especially with the math. When you've got pictures, when you've got diagrams, mark them up, draw on them, write on them, do whatever you've got to do to be able to visualize it and see it. So you can get through that. All right, so our homework on this section is pages 502 to 505, numbers 11 through 27 odds, number 34, 35, and 39. So let's go ahead and take a look at what we're doing in each one. Numbers 11 through 14, we can see here it says determine whether the given information implies that QS is parallel to PT. So I'm looking at my, you know, basically I'm just checking, are my sides proportional? Okay, is this segment over this segment proportional to this segment over this segment? If it is, they're parallel. Is this one over this one to this one? Again, you're just checking to see, are my sides proportional? If they are, then my lines are parallel. If they're not proportional, then they are not parallel. Numbers 15 through 20, use the diagram shown to decide if you were given enough information to conclude that LP is parallel to MQ. If so, state the reason. Okay, so you're looking to see, are these lines parallel based on what they've given you? Do you have enough information? You're not having to solve anything. You're not having to tell any measures. You're just saying, do I have enough information to prove that? Okay. Finally, over on 503, now we start solving. We have measurements and solve, and we use our theorems to find the value of the variable. If you have to look back at the previous examples, look back. Okay. If you don't remember, now what was that? Look back to the examples that we worked through. So on this page, we have got 21 through 27 odds. And then you're going to turn the page to 504, and we are going to do numbers 34, 35. We've got 34 and 35 here. Okay, so again, use the diagram to determine the lengths of the missing segments. So you've got to find, I guess, like, let's see on that one. You need to find AB, you need to find DF, you need to find GJ, and you need to find HJ and FG. Okay, so you're looking for all the missing segments. So wherever you see a missing segment that does not have a measure, you're needing to set up proportions and solve for those missing segments. Again, go back and look at the examples. So notice
would
that
BC be one?
number 34, pardon?
Would BC be a missing segment, right?
Yes, yeah, all of them that you see that are missing measurements, that's what you're trying to get. Okay, so if it helps you, you could say, hey, this is going to be X, this will be Y, this will be Z, this will be Q, and this will be P, whatever you want to do. If you want to name them, so, and this one will be G, whatever. So if you want to give them variable names, you can give them a variable name. So when you plug it into your equation, you've just got one variable instead of having to do side GJ, you can just call it letter G, okay? And so that one is going to go along with theorem 8.6. Okay, so if you're confused on that one, you're going to go back to page 499. Oh, that's not 9. 499, example 3. Okay, you're going to use that one, and then you're also going to use page 501. Example 6 will help you find the measures of your parallel lines. Okay, so you're going to need to, you'll actually have a couple of these examples put together in this one problem. Okay, example 3 is going to help you find your side measures. Example 6 will help you find your parallels. Now in 35, notice the key that I've got right here is I can see that this angle is bisected. Okay, so I can see those 2 marks of congruence that my angle has been bisected. So I know that I'm going to be looking back at example 4. So this is going to be example 4 on page 500 and working through that. Again, you're finding any missing measurement that you can identify that is not marked. Now notice you do not have to worry about the segments inside. You're not trying to find those missing measurements. You want to find P to R. You want to find R to U and L to N. I guess you need to find from S to N and from T to M, whatever. Okay, so just look at each of those that don't have a measurement. That's what you're trying to find. Any questions? And then we've got mixed review on page 505, numbers 45 through 53. Let's take a look at those. Notice that 45, I just gave you one of these. It's the distance formula, okay? You're using distance formula, number 45. And then we've got number 47, place the figure in a coordinate plane and find the requested information. So again, you're going to need to graph these, put these on graph paper for 47 and 49. You're going to draw your pictures and find the required information. And then numbers 51 and 53 are going to be practicing our transformations, looking, and all you're doing is telling what type of transformation it is. Okay? Any questions on that? All righty, so we are right at our break time. So we're going to take a 5-minute break and come back and pick up with 8-7. All righty. Get ready and come on back. So our next section on dilations is kind of a combination from chapter 7 and chapter 8. Okay. So in chapter 7, we talked about our transformations. We had our flips, our turns, and our slides, or our reflections and rotations and translations. So this is called dilations. And we start with an original pre-image, and then we end up with an image. But basically, we either start with a big image and we end up with a smaller one, and that's going to be called a reduction, or we start with a small image and it gets larger, and that's called a dilation. Okay. One of the things that I can remember this by, if you've ever gone to the eye doctor and they had to dilate your eyes, that meant they put drops in there to make your eyes, to make the pupil open, make it bigger. So when you think about a dilation, it means I'm going from something small to something big. Okay. And obviously the word reduction, we know, means to reduce, to make smaller. So those are going to be the two types of dilations that I'm talking about here. So we're kind of combining chapter 7, but we needed to know how to do our proportions and how to set up proportions with triangles to be able to do this. So we know about transformations, but now we also know about proportions, and now we're putting the two together. Okay. All right, so it says in chapter 7, you studied rigid transformations in which the image and the pre-image of a figure are congruent. In this lesson, you will study a type of non-rigid transformation called a dilation, in which the image and pre-image of a figure are smaller. A dilation with a center C and a scale factor K is a transformation that maps every point P in the plane to point P prime so that the following properties are true. So you can see that this is where we're going to start with our notes on 8.7, dilation. Let's look at what we just read and what needs to fill in where. It says a dilation is a non-rigid transformation which a pre-image results in an image that is either I guess I just kind of combine these. Your first blanks will be either a reduction or either an enlargement or a reduction are going to be those first two blanks. A dilation is a non-rigid transformation which a pre-image results in an image that is either an enlargement or a reduction. The center of a dilation is indicated by the letter C, and the scale factor is indicated by the letter K. Okay, so we've just said that our first blanks, I said enlargement or reduction. Center is C, scale factor is K. Okay. Now it says in a dilation, every point P in the plane maps to point P prime, so the following properties are true. If P is not,
What were the last two blanks?
What?
Again?
Okay, so we filled in bullet point 1 is enlargement and reduction. Bullet point 2 is C and K. That's all we filled in so far.
Okay, thank you.
We filled in bullet point 1, bullet point 2. Now we're on to 3. In a dilation, every point P in the plane maps to point P prime, so the following properties are true. Number 1, if P is not the center point C, then the image of point P prime lies on ray CP. The scale factor K is a positive number such that K equals C prime over CP, and K cannot equal 1. So that's that last blank right there of number 1. K equals C prime over CP, and K does not equal 1. What does that mean that K does not equal 1? What would CP prime and CP have to be for K to equal 1?
The same length.
The same lengths, yeah. So like if I had 5/5, that reduces to 1. So that tells me that CP prime and CP are not going to be the same lengths because they cannot equal 1. So if I'm doing something and I've got the same lengths, I know that something's wrong there, okay? So in that one, that was number 1, positive number such that K equals CP prime over CP and K does not equal 1. Number 2, if P is the center point C, then P equals P prime. There's nothing to fill in there. I already had that one. Okay. So if P is the center, then I know P equals P prime. Now, the next thing says, so if we look at our picture, we've already said that we have a reduction or an enlargement. Notice that with a reduction, then that is going to go between 0 and 1. If it's an enlargement, then it's going to be greater than 1. So if you notice in these examples, we have our reduction. Notice that C is not the center point. So we can see that C is not the center point. So I'm using the formula of K equals C prime over CP. So I look and I say, okay, C prime is going from C to P prime is 3 over C to P is 6. When that reduces, that's 1/2. I can see that that is less than 1, and I can tell it's a reduction because it's less than 1. When I look at my next one, again, I have K is equal to CP prime over CP. So CP prime is 5, CP is 2. And notice that 5/2 could become 2.5. That is greater than 1. So I know that's an enlargement. Okay. Obviously, when you see the pictures and you see that I started small and I got bigger, I know that's an enlargement. I don't need the numbers to back me up. But one thing that you will know is that you have set it up incorrectly if you do not end up with a number. You know that you've reversed CP prime and CP. Okay. All right. So let's go ahead and take a look at example 1, identifying dilations. Letter A says,
what's the note on the second one where it says a dilation? I didn't get that one.
Okay, I'm sorry. So on bullet point number 4, is that what you're talking about?
Bullet point number 5.
Okay, 4 and 5. So that was this part right here. The dilation is a reduction if you have 0 is less than K, which is less than 1. And the dilation is an enlargement if K is greater than 1.
Okay, I got it.
So bullet
Thank you.
point 4 is reduction. Bullet point 5 is enlargement.
Thank you.
All righty. So example 1, identify the dilation and find its scale factor. So remember, we're using K is equal to CP prime over CP. Okay. So let's go ahead and take a look at this. If I have K equals CP prime over CP, that means CP prime, notice I've got CP prime, so I'm talking about this section, is 2. C to P is 3. So in this situation, my scale factor, K is equal to 2/3. Simple as that. When I look at letter B, again, CP prime here is 2, CP is 1. So my K is equal to 2. And it's an enlargement because it is greater than 1. So because 2/3 is less than 1, it's a reduction. Because 2 is greater than 1, it's an enlargement. Any questions about that? All right, so now look at the top of page 507. And it says in a coordinate plane, dilations whose centers are the origin have the property that the image of P, which is XY, is P prime, which is KX, KY. So this is the part you're filling in to bullet point 6. So basically, if I'm doing a dilation, then I take my scale factor, which we said is K. K is our scale factor. So when I'm dealing with my coordinate plane, I have to use my scale factor and multiply it by both X and Y to get my enlargement or reduction. So I start with my original points. I multiply by the scale factor. That gives me my prime points. Any questions about that? So if we look at example 2, I can see that I have a rectangle A, B, C, D, and these are my points, 2, 2, 6, 2, 6, 4, and 2, 4. And it says use the origin as the center, and I use my scale factor of 1/2. So that means when I start with 2, 2, I multiply 2 times 1/2. That's going to give me 1. 2 times 1/2, so now I've got 1, 1. On this one, 6 times 1/2, whoops, is going, half of 6 is 3, half of 2 is 1. On my next one, half of 6 is 3, half of 4 is 2. On this one, half of 2 is 1, half of 4 is 2. So now I found my new prime points. So I take my original points, my scale factor is 1/2, so that means I have to multiply everything by 1/2, and I get my new points. So we can see that here we started with our blue figure, and then we ended up with our smaller figure. Remember, 1/2 is less than 1. So I know that my figure, my image, is going to be smaller than my pre-image. Any questions about that? All right, and then it talks about from the graph, you can see that the pre-image has a perimeter of 12 and the image has a perimeter of 6. And again, my perimeter of my smaller one is half of the perimeter of the larger because the scale factor is 1/2. Okay, so therefore the ratio of the perimeters of the pre-image and its image equal the scale factor of the dilation. So here you can see drawing a dilation. You could use a compass to draw perfectly and get your points. We will use, whenever we're having to deal with that, we'll just use our graph paper. All right, goal 2, using dilations in real life. It says example 3, finding the scale factor. We have shadow puppets. A shadow puppet has been used in many countries for hundreds of years. A flat figure is held between a light and a screen. The audience on the other side of the screen sees the puppet shadow. The shadow is a dilation or an enlargement of the shadow puppet. When looking at the cross-sectional view, we can see that triangle LCP is similar to LSH. Okay, so what I want to do first of all is I want to look and see LCP. What they're talking about here is I've got L to C to P. So there's one triangle, and then we have LSH. So I can see then I have this one right here. So just like we worked with a minute ago, I can see I've got those parallel lines. So then I know if I've got those two parallel lines, then this side to this side is proportional this side to this side. So I'm using those same theorems that I just learned in the last section and applying it. Now I've got an enlargement. Okay. It says the shadow puppet shown is 12 inches tall. Find the height of the shadow, SH, for each distance from the screen. In each case, by what percent is the shadow larger than the puppet is equal to LP, which equals 59 inches. Okay, so let me erase this real quick. So they said that LC is equal to LP, and those are both 59 inches. Okay, and then LS, which is going to be my total side. LS is equal to LH, and those are equal 70, I mean, those are each 74 inches. Okay, so then I'm trying to find, we just let, I know that means CP is going to be comparable to SH. They already told us that it is 12 inches tall, so I know the measurement of my figure is 12 inches. So when I set up my proportion, I have 59 over 74 is equal to 12 over SH. That's what I'm trying to find. So I set it up just like I did my earlier proportion. I cross multiply, which is equal to 888. So it is approximately 15 inches. Let me see, just so y'all can kind of have an idea of how they, so if I have 70, so let me say that's 888. So 888 divided by 59 is like 15.05 something, something, something. So they just rounded it. And the main thing is anytime that you write an estimation, if it is not an exact number, always use your symbol of approximate or approximation. The way be like, you know, this means equal to, this means approximately. So if you round, go ahead and be sure to use your symbol so I will know that you rounded to get that answer. Okay. All right, and so then it says to find the percent of size increase, use the scale factor of the dilation. So basically, remember we have K is equal to CP prime over CP. So they said, okay, CP prime is 15, and CP was 12, and 15 divided by 12 is 1.25. So in this situation, I know that K is equal to 1.25. So first I had to find my missing measurement. Then I could plug in my two parallel line measurements and find my scale factor. Any questions about that? All right, so part B says LC equals LP, but now we're at 66 inches. LS and LH are 74 inches. Okay, so now we just do the exact same thing. We plug in 66 over 74 equals 12 over SH. So now we find that our figure is 13.45 inches. Again, I still have K is equal to CP prime over CP. So K is approximately 1.12. Okay, so now the next thing they say is when they look at our percentages, and that's one of the things I didn't read the entire question. By what percent is the shadow larger than the puppet? So if I'm at 1.25 as a decimal, I want you to think about hold up. I want you to think about our numbers here. Okay, so if I made this a decimal, this is 125%, right? That doesn't mean that it's 125% larger than. What you have to think about is my original was 100%. My original figure, so that's my original, and or actually we'll just say my image and my pre-image. Let me do that. So my image was 100% of itself, right? My pre-image, I messed that up. Why am I writing them backwards? Slow down. My pre-image was 100% of the figure. So now my image is 125%. I have to subtract that 100%. So that means that my new figure is 25% larger. Okay. So then when I look at my next one, again, notice that I've ended up with 1.12. I need to move my decimal. That ends up being 112%, but I have to subtract the 100% that my pre-image was, and that leaves it at 12% larger. Is everybody good with being able to find the percent? I have to remember that my original pre-image was 100% of its size, but now this one is a percentage above 100%. So I have to subtract 100 from whatever my new one is, and that gives me the enlargement. All righty, and that's it on this section. So next we have our guided practice. In a dilation, every image is blank to its pre-image. So remember, we talked about how they're going to be different sizes, but my shapes are going to be exactly the same, right? And what is our word that means same shape, but not necessarily the same size? It's going to be similar to, okay? Remember, congruent means it's exactly the same size, same shape. Similarity means it's just going to be the same shape, but my size is going to be different. So when I have a dilation, it's going to be a similar figure. Number 2, error analysis. Katie found that the scale factor of the dilation shown to be 1/2. What did Katie do wrong? Okay, so if she said it was 1/2, then that means she did 2 over 4. That gave it 1/2. But notice that would be CP over CP prime. And remember, my formula is CP prime over CP. Therefore, it should be 4 over 2, which equals 2. So that was her mistake, is that she did CP over CP prime instead of CP prime over CP. So if you can't remember that formula, look back at the section when you're doing your homework, okay? It says, in the dilation shown, is the dilation shown a reduction or an enlargement, and how do you know? So remember, back from chapter 7, my letter by itself is my pre-image. My letter with the prime figure is my image. So I'm looking and I said, hey, it started little, it got bigger, it's an enlargement, okay? And then also when I look at the scale factor, remember we said the scale factor was 2. 2 is greater than 1. That tells me it's an enlargement. All right, the next one says triangle PQR is mapped onto triangle P prime Q prime R prime by a dilation with the center C. Complete the statement. So it says triangle PQR, is it going to be similar to or congruent to P prime, Q prime, R prime? If we have a dilation, remember, the only thing that's going to change is going to be my size, so it's going to be similar. It's not going to be congruent because my sizes are not the same. All right, if C prime over CP equals 4 over 3, then is my figure larger or smaller than PQR? And the dilation, is it a reduction or an enlargement? So I've got to look at 4 over 3. Is that less than 1 or greater than 1? It's greater than 1, so it's going to be larger, and it's an enlargement. Any questions on that? And number 6, use the following information to draw a dilation of rectangle ABCD. All right, so it says I have 3,1, 3.25. I'm sorry, I have A is 3,1, B is 3, 2.5, C is 5, 2.5, D is 5,1. Use the origin as the center and a scale factor of 2. So again, I know that for A, I started at 3,1, Now I need to multiply both by 2, and 3 times 2 is 6, and 1 times 2 is 2. So A is going to become 6.2. B started out as 3, 2.5. Okay, so 3 times 2 is 6, and 2.5 times 2 is 5. Letter C, I started out with 5 and 2.5. Multiply both by 2. 5 times 2 is 10. 2.5 times 2 is 5. And then letter D, I started out with 5, 1. 5 times 2 is 10. 1 times 2 is 2. So here are my new numbers. So now I'm going to go ahead and plot those. So I can see now I've gone to 6, 2. 1, 2. And then 6, 5. So that's already 6, 2, 3, 4, 5. And then 10, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. And 10, 2. So now I can see my enlargement. Again, like in the pictures, they would always connect and say, okay, from my origin, I had here to here, then here to here, and then here to here, here to here. So we can see where our lines are showing our enlargement. Okay. All right, so our homework in this section 9 through 31 odds. So starting on page 8-7, we have numbers 9 and 11. Identify the dilation and find its scale factor. So you're telling, is it a reduction? Is it an enlargement? And then what is the scale factor? This is where you're using K equals C prime over CP. The next one, number 11, identify the dilation, find its scale factor, then find the variables. Okay, so now not only am I going to have to do my K equals C prime over CP, now I also have to set up my proportionality statements to show what are my measurements. Okay. Turn the page to 510 and we pick up with numbers 13 through 21 on this page. Numbers 13 and 15, you can see that it says we need to use the origin as the center of the dilation, and given a scale factor, find the coordinates of the vertices of the image of the polygon. If you want to graph it, you're more than welcome to, but in this situation, I'm just having to find the coordinates. Okay, so I need to find what are the coordinates of P, Q, and R, then multiply it by my scale factor to find my new coordinates. I don't have to find your coordinates of S, T, U, multiply by your scale factor of 4. 17 and 19. It says copy DEF and points G and H as shown, then use a straight edge and a compass to construct. Oh, I meant to delete those. Delete 17 and 19. You don't have to do that. 21. Let me make a note to myself too. Nine through 31 and 19. Okay, 21, the red triangle is the image of the blue triangle after a dilation. Find the values of the variables, then find the ratio of their perimeters. So on this one, notice that first I find my measures, and then I do my ratios of my perimeters. Okay, so you're going to need to look back at example 2 on page 507 will help you with that. (23) Triangle ABC is mapped onto triangle A prime, B prime, C prime by dilation. Use the given information to sketch the dilation. So that means you're going to need to graph it, sketch it, do what you need to do, identify the reduction or enlargement, and find the scale factor, and then find the missing lengths. So it tells you AB is 5, BC is 7, A prime, B prime is 20, A prime, C prime is 36. So you need to find the lengths of A, C, and B prime, C prime. Okay, so sketch it, graph it, do what you want to do to be able to find those missing lengths. 25, you're projecting images onto a wall with a flashlight. The lamp of the flashlight is 8.3 centimeters away from the wall. The pre-image is imprinted on a clear cap and it fits over the end of the flashlight. The cap has a diameter of 3 centimeters. The pre-image of the height is 2 centimeters and the lamp of the flashlight located is 2.7. Number 24 says to sketch a diagram of the dilation that will help you to find the diameter of the circle. And we may end up doing that. I want you to attempt number 25, but we'll definitely go over that one and how to do that. Okay. 27, find the scale factor of the enlargement. It has given you information in the directions on what to label as what. I would recommend drawing it, labeling it. And then 29 and 31, again, we are using the diagram from 27 to determine the missing information, okay? So you're using your scale factor to be able to find these missing numbers. Then we have mixed review, pages 513, 39 through 43. So notice 39, refer to the triangle shown, use the Pythagorean theorem, a squared plus b squared equals c squared. In 39, they have given you a and c, you're gonna have to solve for b. Number 41, they've given you b and c, you're gonna need to solve for a. And then number 43, again, we have isosceles triangles. Determine whether the triangles can be proved similar or not, based on the fact that I have two sides that are congruent and an angle that is congruent. Can you tell that they are similar, and what is the reason why you're telling that they are similar? I will tell you it has something to do with the fact that you have two congruent sides and a congruent angle in between them. So hopefully you're already looking at that and going, hey, that is side angle side. All right. Then we get to our chapter summary, pages 516 through 518. So I want you to go through your chapter summary and chapter review. Okay. I'm sorry.
I accidentally pressed unmute.
Okay, that's fine. So we've got, this just walks us through, this is your review to prep you for the test, okay? So we'll go through the chapter review. So let's see. So for homework between now and then, you've got 8-6. I tell you what we'll do. You've got homework for 8-6 and 8-7. The chapter summary is going to be where we start next Wednesday. We will do the chapter review together. Okay, so your homework is going to be from 8-6, pages 502 to 505, and then the mixed review on 505. Then the assignment from 8-7, pages 509 to 511, and the review on 513. On Wednesday, what day is that? Today is the 4th, next Wednesday is the 10th. Next Wednesday, we will check homework. We'll do our chapter review. We'll go through this review together to prep for the test. You will get the test on Thursday of next week, okay? So you'll get your chapter 8 test next Thursday, but then we're out for winter break. So your chapter test won't be due until the Monday we return, I mean, the Wednesday we return after winter break, okay? So our plan for right now, your homework due next Wednesday. You do not have to submit it. You can hang on to it all. We'll turn it all in together with the chapter 8 test. But you need to have completed by next Wednesday, pages 502 through 505 and the mixed review 505, pages 509 through 511. And I'll go ahead and remember, these are the things. So basically I've got, this is from 8.6, 8.7. We're omitting number 17 and 19. I have a note here that we're going to start with that chapter review on Wednesday, the 10th. Okay. Any questions on what you need to work on between now and next Wednesday? Everybody clear? And it is 10:03. So we are done for the day. We'll go ahead and sign off a little bit early. That'll give you a few minutes before your next class. If you have questions, if you need help between now and next Wednesday, be sure to let me know. Okay. But like I said, there will be some that we'll definitely go over when we check our homework next Wednesday. But if you need help between now and then, let me know.
Bye, Miss Jennifer.
Thank you, Miss Jennifer.
Thank
All
you.
right.
Bye.
Bye, guys. I hope y'all have a great weekend. Bye-bye.